Hey guys, welcome to Tech.to.tinker. My name is George. Recently, I received a pair of LoRa transceiver module from Reyax Technology. So in today's video, we will learn how to use the RYLR896 LoRa module of Reyax Technology by interfacing it to an ESP32 and to a Raspberry Pi Pico using MicroPython language. Reyax Technology is a company based in Taiwan. They provides a variety of embedded solutions ranging from cloud, Wi-Fi, Bluetooth, LoRa, ISM radio, NFC, GPS, and a lot more. So you can check it on their website, reyax.com. The LoRa RYLR896 module provides ultra-long-range spread-spectrum communication with high immunity for interference. This module provides an easy-to-use solution by sending 80 commands using UART serial communication protocol in order to communicate with this module. This module has 6 pins, namely, starting from left to right or VDD or supply voltage. According to the datasheet, this module can have a minimum of 2 volts up to a maximum of 3.6 volts. So definitely, its UART transmit and receive pin will use a 3.3 volts logic level. So we don't need any voltage level conversion when using the ESP32 or Raspberry Pi Pico. Pin number 2 from left is NRST or active low reset pin. Pin number 3 from left is RXD or the UART serial receive pin. TXD or pin number 4 from left is the UART serial transmit pin. Pin number 5 is not connected and it is not used. And lastly, pin number 6 is GND or ground pins. For your reference, there is a PCB markings at the back of this module. Yeah, here. There is a PCB markings for your easy reference. I already have it connected to microcontroller development boards for ESP32 and Raspberry Pi Pico by providing 3.3 volts as a supply voltage, and the grounds are tied together to provide common grounds. Now the LoRa TXD is connected to microcontroller's RXD pin, while the LoRa RXD is to microcontroller's TXD pin. The LoRa reset pin is not used for simplicity purposes. But if you like, you can connect it together to microcontroller's reset pin so that when microcontroller is reset, so the LoRa will also be resetted. Or you may assign a dedicated pin for it so you may reset the LoRa transceiver independently. For your reference, the circuit diagram will be posted in the companion blog post for this video. Links in the video description. Now for the software part, I have here a 2 source code. One for the ESP32 and another one for the Raspberry Pi Pico. And in case you are wondering how I am able to run 2 instances of Tony, I am currently using a portable Tony. The other one is run inside the Sandboxy Plus. This way, you can run 2 instances of Tony at the same time and take advantage of the REPL capability of MicroPython. Now to communicate with the RYLR896 LoRa transceiver, I created a simple Python class to simplify the coding process named RYLR896 class. The source code for the Raspberry Pi Pico and the ESP32 are identical. So they use the same copy of class. And here, I also pre-configured that the LoRa transceiver connected to the Pico will be assigned with 1 as an address, while the LoRa on ESP32 will be assigned with 2 as an address. I also changed the UART pin assignment for the ESP32. Now, with the help of the class I created, we can easily test the communication between the LoRa and the microcontroller. Let's run it first. Run. Run. Now, our Pico is assigned to an address of 1, while the ESP32 to address 2. We can send LoRa.test. And it replies OK. Here also, we can test LoRa.test. And it replies OK. If it replies OK, then it means you are connected to the LoRa module. Else, there could be a problem between the LoRa module and your microcontroller. Also, down here are the list of errors from the LoRa module. There are 15 sets of 80 commands available in RYLR896, but I will not go through it all. I will just show you the basics. Anyways, this is available in Reyax website. So you may download it and you may refer to this 80 command for the RYLR896. Here are the basic rules used in these 80 commands. Let's say, to set an address, you will send 80 plus address equal to the address you want to set. And if you want to query the address, you just need to send 80 plus address question mark. And another one, it is required to put a \r\n at the end of all 80 commands. Now let me demonstrate how you can use the class that I created to test your LoRa module. So let's go back to the source code. I already showed you the test method, which is the LoRa test, which is this one. Now we can set the address. Let's say this one is set to 1. We can set it to 3. Let's say LoRa that set address to 3. Open and close. Hit enter. Now the address is set to 3. Let's set it back to 1. LoRa that set address 1. To send a message to the other LoRa module, we can use this method. So that is LoRa that send message. Then you will provide the address. The address of the other one is 2. So 2 and the message. This one. So the message is, let's say, hello. And hit enter. When it replies OK, we can read it on the other side by using the read message method. That is LoRa read message. And as you can see, the message is here. It says, it received from the address 1, which is the LoRa module connected to Raspberry Pi Pico with 5 bytes, which is HELLO. This is 5 bytes. And these are the RSSI, and this is the signal to noise ratio. Here. RSSI and the signal to noise ratio. Now, let's say we reply to the other side. Let's say LoRa that send message to address 1 with a message tech.to.tinker. Hit enter. Now, let's read from here. LoRa read message. And we receive it here. Now, in case you want to test other commands, let's say, let's check if what is the current address of the module. We can use the AT plus address question mark, this one. Let's copy this. And let's send it using LoRa.cmd and the command we want to use. We don't need to put the \r/n because it is already added here. Enter. And the address is replied. As of now, with MicroPython ports for Raspberry Pi Pico, it can only have a maximum receive buffer of 32 bytes. There is no problem with the ESP32, which have 256 bytes of buffer. So let's say when we send from ESP32 to Raspberry Pi Pico, the message will be truncated. So let's send a message, LoRa.send message to 1. Let's say 1, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I think that's enough. Hit enter. Now let's read from here. LoRa.read message. It's all received. Let's add another 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a total of 0 on 9. So this is 10, 20, 30 bytes. Hit enter. And let's read again here. And as you can see, there are values that is truncated because it can only receive up to 32 bytes. But if you send to the ESP32, there is no problem. Let's say, let's send LoRa.send message to 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. And hit send. If we read it here, read message. And as you can see, it is all received in the ESP32. But in Raspberry Pi Pico, it can only accept up to 32 bytes. So that's all for now. I hope you learned something from this. As always, the details and other information for your reference can be found in the companion blog post for this video at tech.to.tinker.blogspot.com. Links in the video description. If you find this as helpful, please like and share this to your friends so that it can reach more people who might benefit from this. If you are new here, please consider subscribing and turn on the notification bell because I will be uploading more videos like this in the future. Thank you and have a good days ahead. See you next time. God bless.